Welcome to Facts Before Fantasy.
What if I told you that at the smallest scale of reality, particles don't have exact positions? Instead, they exist as possibilities. This strange idea is captured by a single mathematical object, the wave function, usually written as psi. Today, we're going to understand what the wave function really is, without drowning in math. In classical physics, life is simple. If I throw a ball, I know exactly where it is and where it's going. But in the quantum world, particles behave more like waves, spread out, blurry, uncertain. The wave function is our mathematical way of describing this weird behavior. The wave function, psi, x, t, is a function of space and time. But here's the twist, psi itself is not directly observable. Instead, the square of its magnitude tells us something physical. Psi, x, t, superscript 2 equals probability density. This tells us how likely we are to find a particle at a certain position.
If psi superscript 2 is large in a region, the particle is likely to be found there. If it's small, the chance is low. The particle doesn't travel along the wave. The wave represents our knowledge of where the particle might be. The wave function doesn't evolve randomly. Its behavior is governed by one of the most important equations in physics. The Schrödinger equation. I del t del psi equals minus 2m2 nabla 2 psi plus v psi. This equation tells us how the wave function changes over time. Unlike classical waves, psi is usually complex valued. That means it contains imaginary numbers. This allows interference, where waves add and cancel, a purely quantum effect. Before measurement, the particle exists in many possible states. The moment we measure it, the wave function collapses. Suddenly, probability turns into reality. A famous example is the particle in a box. The wave function forms standing waves, only certain shapes are allowed. This leads to quantized energy levels. The wave function isn't a physical wave. It's a wave of possibility. And yet, it predicts experiments with astonishing accuracy. Reality, at its core, is probabilistic.
The wave function is the heartbeat of quantum mechanics. Strange. Mathematical. Beautiful. If you enjoyed this, like, subscribe, and let me know. Should we explore quantum entanglement next?
Welcome to Facts Before Fantasy.